In the last video, we solved the simple circuit using equivalent resistance as well as Kirchhoff's voltage law. Today, I want to introduce two other tools that can make your analysis even easier. Basically, we're going to introduce the voltage division formula and the current division formula. You can derive these two formulas based on KVL and KCL and Ohm's law, but I'm just going to give them to you, and they can be handy tools for the circuits that you solve. So the voltage division formula says that if you have a string of resistors that are in series connected across a source, I'll just draw 3 for now. So we have R1, R2, and R3. And we have a source voltage here. And you want to know what is the voltage across each resistor. And this is assuming you have a voltage and it's across just a string of series resistors. If you have like other parts of the circuit connected to it, then it may not necessarily work. So, but in this simple case, let's say we wanted to find, or actually, I'll go ahead and I'll label all these voltages VR1, VR2, and VR3. You could apply KVL and Ohm's law in order to find these voltages. But actually what you can do is you can apply the voltage division formula, which says that VR1 is equal to the supply voltage times R1 divided by R1 plus R2 plus R3. In the same way, VR2 is equal to R2 divided by, oh, actually, we need that VS term, VS times R2 over R1 plus R2 plus R3. In the same way, VR3 is equal to VS times R3 divided by R1 plus R2 plus R3. So the point being is, if you have a string of resistors all connected in series and you have a voltage across them, to find the voltage across any one of the resistors, you simply take the voltage that is applied across the whole string of resistors and multiply it times the resistor in question that you're wanting to know the voltage of, divided by the sum of all the resistances. In this example here, I've just drawn 3 resistors, but it actually works with any number of resistors. So this is a useful principle that can be used, and I will show how it can be applied to the example that we had in the last video. Before I do that, though, I also want to introduce the concept of current division. There's a similar formula for current division. It's a little less it doesn't work. It only works for 2 resistors. It doesn't work for any number of resistors, but it's pretty similar. And this is the formula here. So if you have 2 resistors and they are in parallel, and you apply a voltage, we'll call it Vs, make this red, Vs across these 2 resistors in parallel. We'll call this one R1, R2, and you want to know how the currents split between the 2. So we have, how do they divide? So we have I1 and we have I2. What the current division formula says is that I1 is equal to actually, I made a mistake here. I don't need to label this voltage actually. What I want to say is if you have two resistors and you have a current, a total current, IN, I'll call it. So you know that a certain current is coming in into two resistors that are in parallel, and then it rejoins, coming out as IN. The question is then, what is I1 and I2? That'll be input current times the opposite resistor, which is R2 and then R2 divided by the sum of the resistors. And then I2 is going to be equal to IN times R1, the opposite resistor, over R1 plus R2. So that's just kind of a handy tool to keep in the back of your mind. I would recommend you should have both of these formulas memorized. It will make your life easier. So let's think about how we could have applied like the voltage division formula in our previous example. If you remember, using equivalent resistance, we simplified the circuit into something like this, where we had plus or minus V0, and this was Vs actually, and then we had R12 and R34. And previously what we did is we defined like a current and did all the KVL analysis and all of that. But here, notice here now, it's a lot more straightforward with the voltage division formula. Here we can just straight up solve for what we want, which is going to be Vs times R34 over R34 plus R12. So we didn't even have to do a KVL loop. We just, based on this simple circuit, series circuit, we are able to just directly apply voltage division. So that's an example of how having these things like in the back of your mind can really be helpful in simplifying problems. Thanks for watching, and I will see you in the next video. Hello everybody, thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So, she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?